Hi everyone. So now we will discuss about the past year 2020 semester 2 the repeats paper. So in part 1 I will explain the question number 1, 2 and 3. First, question number 1a is asking us to evaluate the limits of x squared minus 4 divided by modulus 2 minus x, where x is approaching to the positive 2. And here we need usually method we will substitute x equals to 2, but when we substitute x equals to 2 you will find out that the denominator is turns into 0. So then when the denominator turns into the 0, the whole things become infinity or undefined, at least in the real axis. We are not talking about the imaginary axis here. Okay, so however, to solve the undefined problem, we need to first expand the x squared minus 4 into 2 minus x multiplied with minus 2 minus 2 minus 2 minus x, sorry. Then you will find that it can be cancelled with the denominator. However, how about the polarity? How we know the polarity of the x equals to 2 plus? When we are talking about x approaching to 2 positive, the x is actually not equals to 2. It's greater than 2. It means that 2.0001, 2.1, 2.2 is not equals to 2, but is approaching to 2 and greater than 2. So we can deduce that the two of the numerator in your showing here is actually negative, because 2 minus the number greater than 2, you will find it was negative. So negative, you will get positive. Positive divide by positive, you will get back positive. So that is why our 4 is the positive 4. Else, if you are cancelling the numerator and denominator, and then you direct minus in that way, you will find out that this will be the negative 4. However, negative 4 is incorrect in these terms. So we must take note of this thing and this thing, which is x not equals to 2 and x greater than 2. So we come to the next question. The limits of surt x plus 5 minus surt 5 divided by x, where x approaching to 0. In this question, we can observe that the numerator have two terms, 1, 2. Usually in this case, we will multiply by the rational. Rational means that is the exact terms, except this, the central sign, we change from the negative to positive or positive to negative, vice versa. This is what we call rational. Another terms is the conjugate. The conjugate happens to be when this thing is in imaginary axis. So now we are calling it as rational. We are not calling it as a conjugate because there is no imaginary axis there. So now when we multiply with the rational the numerator must equal to the denominator, so that it is mathematically consistency there. And then we substitute x equals to 0, we will get this answer. So next, question number 2, the parametric equations of a curve are x equals to 2 cos cube theta and y equals to surt 3 sine cube theta for theta in between 0 and pi. Find the equation of a normal to the curve where theta equals to pi over 3. So we need to find the equation of normal to the curve. What is the equation of normal to the curve? It means that we must find the dy dx first. Dy dx is the gradient or the tangent to the curve. So in order to find out the dy dx, we must use chain rule, because the x is in the theta term and y is also in the theta term. So in order to find out dy dx, we must first multiply dy d theta with the d theta dx. And d theta dx is actually dx d theta. You inverse it, you will get the d theta dx. And the tangent of the curve is actually, this is our parametric curve. Parametric, it means the quadratic curve as well. This is the parametric curve, and then the tangent is the straight line who cuts through the maximum point at here. And the normal to the curve is actually the orthogonal lines to this straight line. So we call it as a normal to the curve. So we need to inverse the dy dx at here and multiply by negative 1. We will get the normal of the curve. So x equals to 2 cos cube theta. When we dx d theta, we will get negative 6 cos cube theta sine theta. So this thing clear. And then we differentiate in terms of theta of y. We have found 3 surt 3 sine cube theta cos theta. And we apply chain rule. We inverse this d theta dx. Inverse this thing. And we bring to here. After the calculations, we will actually finally we will get dy dx, and this is the gradient of our equation of tangent. So Now we apply the exact point. This is what we call exact point. It means that the particular point on that curve is given by the question. So we call it as a particular solution, or the particular point at there. So hence the equation of a tangent is actually, we bring this gradient to here, y minus y1, x minus x1, and this is y1, this is x1. Substitute, we get this thing. This is the equation of tangent. Then we multiply the gradient of this equation of tangent. We inverse it and multiply with -1. We will get the gradient of normal. The gradient of normal. Apply again the same method, y minus x1, with this gradient, x minus x1. We will get the equations of normal at here. In question number 3, state the constants a and b such that the x plus 1, a times x plus 2 plus b. Hence, find the integral of a x plus 1 divided by x squared plus 4x plus 8 dx. So this is an indefinite integral. We must make sure, we must clear what is a definite integral and indefinite integral. The indefinite integral means that later in our answers, we must plus c inside, and we need to find out the value of c, if required. So at here, x plus 1 equals to a times x plus b is actually our hint to use the completing the square method. I believe if you have taken your SPM, you should know what is the completing the square method. Usually, we know that in this format, something something squared the functions plus a constant usually it is a similar form to hint you to use the completing the square method. So after we factorize out the thing and then we rearrange, we found out that the a is actually the x plus 2 and b is the constant. So this is the completing the square format. You should bear in your mind. Using the substitution method to do the integration. Why we need to use a substitution method? It is to simplify our work. Okay, so we let u equals to x plus 2. Let u equals to x plus 2. Because you see, when you here got the x plus 1, here got x plus 2, 2. Even though you are trying to use the ln format to solve the integral, is impractical because this one is 2x plus 4. And this one 2x plus 4, how you going to arrange this thing into 2x plus 4? If you multiply by 2, you will only get 2x plus 2. So that's the difficulty if you try to use the ln properties in the integrations. Hence, we must use the substitution to solve our problem. So this method is not recommended at here. So when we differentiate both sides with in terms of x, we will get du dx equals to 1, where du equals to dx. It means we can direct substitute the dx here into du. Then we substitute x plus 2. So x plus 1 equals to u minus 1. Here, numerator. Here, the denominator. One thing you need to take note, since this one is the indefinite integral, we don't need to care about the limits, upper limit and lower limit of integral. Because if you're using the substitution method, you should take note in your definite integral, this thing need to convert in terms of u as well. Otherwise, you will substitute the wrong thing. Else, when you complete your integrations, you need to turn the u back to x and then only you substitute your limits inside. That's the way to make sure your method is in consistency. So we're using the sum rules of the integrations. We split it into 2. After that, you can apply your ln properties inside your integrations. So it will be the half ln u squared plus 4 minus half arctangent u over 2 plus c. And then you apply inside. This is a ln property which I mentioned just now. And then you can substitute u equals to 2 tangent theta. And then you continually solve. You will get this one. 1 over u squared plus 4. When you integrate this one, how did I get the tangent inverse? How do I get this term? So here are the key I'm using. Here are the key I'm using. You see, when du equals to 2 secant squared theta d theta, so 2 secant squared, we squared it, it will become the, u is at here. So when we put it inside, it will become 4 tangent squared theta plus 4. And we know that 1 plus tangent squared theta is equals to the secant squared theta. So that's the point. when we cancel off, we will finally get this thing, half of arctangent u over 2. So up to here, we will continue this in our next video.